So I want to kind of keep immersing you guys in the chain rule. I kind of purposely give you a lot of examples to look at today. Tomorrow you'll get a chance to try a few things and see if you're approaching this the right way. All right, so now remember, these examples, they could not have been derived without this new rule. Okay, so what we're saying is we want to realize that there's something new about them. And then, of course, we want to apply this new rule correctly. So we've got here y equals the sine of the cosine. The sine of the cosine. Now listen, it's important that you not interpret this as sine times cosine. It's not sine times cosine. If it was, we'd have an extra x and we'd have a product rule. Okay, so this is not the product rule because it's not a product, but it is a chain rule. Again, for that simple reason that there's two functions and one of them's on the outside and one of them's on the inside. Okay, now here we go again with the parentheses. The parentheses often show us the inside. That would mean that this sine is the one on the outside. Now, what we want to be careful is that we don't just sort of do the derivative of sine and cosine. Are you hearing me? We're not just going to do the derivative of sine and cosine. We're going to carefully use the chain rule to do the derivative of the outside. Now, the derivative of the outside would be the derivative of sine, which is cosine, but we're going to leave the inside alone. We're going to leave cosine alone. Notice again, I did not write like an extra x. It's the cosine of cosine. And then you're going to multiply, you're going to chain one to the end of this, the derivative of the inside. So the derivative of cosine is negative sine. Honestly, this answer is fine, but it's more that we understand this is it. Like it's not cosine squared because it's not times. It's not a product. We just simply kind of worked out the chain rule, and the answer you get, there's nothing else really that needs to be done. Now, maybe the negative sign you would see in front of the answer in the solution manual. That looks a little better like that. Make sure you see all the parts of the chain rule. The derivative of the outside. That's this green cosine. The inside left alone. And then the derivative of the inside. All right. I have a circle around this one. Make sure that we do this. I'm just going to go ahead and put it down here. All right, I've got 2x squared and 4x plus 1 cubed. 2x squared, 4x plus 1 cubed. Okay, now, we're kind of immersed in the chain rule. It's kind of like front and center. So I'm sure that you see what's going on over here. This 4x plus 1 inside, this cube outside. Okay, people see that. But actually, what I would rather you see, and what I want to kind of focus on that you see, is this product right here. Okay, honestly, that product symbol, maybe it's a little more important than the chain rule. Okay, because that product is actually kind of our main roadmap. Okay, I like to think of this as the main roadmap that will take us to the derivative. What I'm talking about is the product rule. You have to see the product rule as kind of like the guiding rule that's going to allow us to do the derivative of this function. Now, if you're saying, what about the chain rule? Well, we will do the chain rule. Yes, we will do the chain rule right here when we get to that. And what I mean is when we get to the derivative of the second, okay, so the product rule says first derivative of second. So we're following the product rules, our main roadmap. So first, kind of just copy down the 2x squared, derivative of the second. Okay, well, that's when you're going to use the chain rule. Okay, when we do the derivative of the second, we're going to think of that 3 as being on the outside. And like we've done now a couple times, we'll leave the inside alone. Don't forget to finish the derivative of the outside. So that square that I wrote down there, that's pretty important because that's part of the chain rule. And then, of course, I'm going to then multiply by the derivative of the inside. I'm going to multiply by 4. So we've got 2x squared times 3, 4x plus 1 squared times 4. Now, do you guys understand that what I wrote here is only half of the product rule? Okay, we still have to finish the product rule. Sometimes, once again, people are so excited about the chain rule that you kind of forget to finish the product rule. And to finish the product rule would be to do the second. So we just copy down the second, and then the derivative of the first. The derivative of the first would be the derivative of 2x squared. Nice little 4x. It's important that you see the product rule as the overall roadmap, as what's guiding us through this derivative. Yes, we did the chain rule when we had to do the derivative of the second, and that used the inside and outside. Okay, but it's really the product rule that kind of took us beginning to end. There's some stuff that could be simplified here. 2, 3, 4. Okay, they're all coefficients that can be multiplied to be 24. X squared. Looks like that just kind of stays as is. So we need to be able to get 24x squared times 4x plus 1 squared. And then I guess really not much happens over here. Just recopy. We tend to write the 4x in front just because, again, it's kind of a, I don't know why the 4 would come in front, so the x can kind of come along with it. Now, listen, what's written here is right. It's completely right. I would give you full credit for it. When you look in the solution manual, they like to factor. I want to show you the factoring just so you're kind of like aware of how they got to that final answer, and that if you go back one step, you'd be where we are. Basically, you could factor by looking at some of these terms and realizing that they are common, like 24 and 4. Okay, I could pull 4 out of that. X squared and x. I could pull an x out of that. Okay, and then 4x plus 1 squared compared with 4x plus 1 cubed, I could actually take out a 4x plus 1 squared. Now, the kind of factoring I'm doing here is known as Gcf factoring, where you take out like the greatest common factor. Just by the way, if you're saying, I don't need to do this, right? Yeah, you don't need to do it, but you should be aware of it because there are some problems where when you factor, something will cancel. Nothing's going to cancel here because we don't have a fraction. But I still want you to see the factoring. It looks like we're left with a 6. Looks like we're left with an x. Okay, the 4x plus 1 squared, that's all factored out. And then over here, I'm left with a 4x plus 1. Again, nothing's going to cancel, so it's not really that imperative, but it does turn out that inside the parentheses you have some like terms. So it is a little different looking answer. If you look in the solution manual and you're like, how did they get 10x plus 1 factoring? But I'll give you credit for what we had before. Okay. The most important part of this problem was this invisible dot. It told us to do the product rule. If we didn't do the product rule here, we're going to have a hard time coming up with that derivative. Math party problem. Math party problem. Type of problem we pull out sort of when the party's getting a little bit stale, need a little excitement. Pull out the math party problem. Basically, that's Miss Naylor's code for good problem. Probably has some special thinking. Okay. Maybe it's a little harder. Maybe it's just that we have to think about it carefully. Okay, so why is this a math party problem? Why is this a math party problem? I'm trying to get you to the point, even though it's just the first day, but I'm trying to get you to the point as soon as possible that you recognize that there's multiple functions. Okay, there's multiple functions. You should be looking at the cube, the cosine, and the 2x and saying those are all functions. Okay, in this case, we have an outside function of 3, but we actually have what we'll learn to be like 2 inside functions, sometimes thought of as the inside and then the inside. The inside and the inside. But bottom line is we have 2 inside functions. Okay, what are we going to do about that? Let me rewrite it for you. What we're going to do about this is ultimately we're going to think of it like this. This is pretty important here. This kind of problem we'll continue to talk about, but I really want you to try to take in what I just did, and that is that I'm putting the cube literally on the outside. Now, let me make sure I'm clear. What I'm doing here is I'm telling you that's how you have to think of this problem. And you can rewrite it too. But you understand I didn't do any calculus yet. I didn't do the derivative. I didn't do the chain rule. But it's so important that you recognize that that cube is the number on the outside, which then makes it, I hope, really clear that cosine's on the inside. And then this is where I'm getting at this inside. There's this other function on the inside. And what we're going to do is we're going to kind of work our way through the chain rule. We're going to work our way through the chain rule. I hope that the beginning of the chain rule is pretty straightforward because, as we've done many times, it's the derivative of the outside, with the inside left alone. Okay, so straight up, just drop down the 3, change it to a square. You just did the derivative of the outside. Now, when you get to the inside, kind of like one of those, help me out if somebody knows, they're like, it's like a doll or some type of like craft where you like open it up and there's another one in there. And you open it up and there's another one.
Is it the Russian marionette doll?
I don't know. Is it? Okay, here's some yeses. I just thought it was some type of nesting dolls or something. I guess I've seen boxes where you open up the box, there's another box. But you get the idea. We open up the box, we open up the doll, and we open up the cosine. What I mean is we do the derivative of cosine, okay? Now the derivative of cosine is negative sine. So we open that one up, we did negative sine, but we have to leave the inside alone. And when we open it up and we leave the inside alone, of course, we see that there's another inside. And so we do the derivative of that one. So you have to kind of work your way to the inside. This 2 that we're putting on here, it's like a double chain. It's a double chain. In other words, there's 2 insides that required us to do each derivative. Okay, just take it in a little bit. I want to slow down. All of that was based on the original. Okay, the original seemed pretty simple, but the chain rule sort of takes it and you end up with this long answer with basically all these chains on it. 3, negative, 2, okay, that kind of thing. I know it seems like we keep talking about it, but you need to take those numbers and multiply. 3, negative, and 2 gives you negative 6. After that, it's kind of up to you what you decide to do. Some people would kind of rewrite the answer a little bit back to how it was, like cosine squared with the square there. I'm going to go ahead and produce that answer. It does look a tad bit simpler. Okay, now trig functions often bring this along, okay, because when you have a trig function and an exponent, just to highlight it one more time, you have to think about it like this. You have a trig function with an exponent. Think about it as that large exponent on the outside. Okay, just want to make sure we're kind of doing what you guys need. Let's make this our last problem, but it kind of is 2 problems, okay? 2 for the price of 1 here. We're going to do a little compare contrast. You've seen a couple things. I guess I'm curious how you'll approach Okay, so we have y equals the cosine of 2x plus 1. Y equals the cosine of 2x plus 1. And then we have y equals 2x plus 1 times the cosine. Now, I'm not trying to imply that these 2 problems have to be tricky, but trying to get you the idea that they're different. So how do we approach them? How do we sort of compare and contrast them? Why don't you try them? Why don't you kind of think about them? You should be getting 2 different answers, but how different are they? Let's do this just for a simple but I hope effective way to compare and contrast these. Let's say girls, since there's all 4 of you, you're kind of somewhere around here. Girls, will have you do this one. So talk about it a little bit, figure out what the right answer is, and then ultimately will someone kindly explain it. And guys, since you're kind of more over here, if you want to just spend a moment making sure that you understand that, and if someone can explain it, I'll give you a couple moments to talk to your group.
I get a difference for the second.
Oh, no.
See if you can just come to a conclusion about your problem.
Well,
Oh, wait,
and then, yeah.
Can you also have a spokesperson? Can you also have a spokesperson?
Well, that's why I have friends. Like that way we don't do this. Where did you? What? Oh, yeah, that way. Oh, okay. That way, I just, you would end up. Like, you would distribute. Which one?
No, okay, you were from Cosine.
Well, yeah, I mean, I'm just gonna distribute it.
Yeah.
Oh, yeah. Okay, so she was. I gotta hide these. Plus. Yeah. Okay.
Well,
It's not really good. It's on the side. Other from below. It was so
All right, so can we hear from the two groups? Do you have someone that knows what is going on and wouldn't mind explaining it?
Do you want us to?
I'm going to go ahead and just let you be the voice of the calculus. I'll be the face. So, guys, who's got the stuff here? Love to hear from you. Go ahead. Okay. right. And guys, you can sort of thank the girls for having to kind of do the trickier one, but either way, I like what you said, that you say it's just the chain rule, okay? Because it's just the chain rule. But if you sort of contrast that, girls, of course, it's not just the chain rule. In fact, who's your spokeswoman?
All right, I'll do it. Okay, so we did the product rule, so it's the first, we just do it with one.
Let me just stop you. I know people are getting this, but I just want to highlight, and you're exactly right. It's a product rule. So, okay, go ahead.
Okay, so it's the first time for the second, so 2x plus 1 times negative 9x plus cosine x times 2.
Good. And how'd you get cosine x times 2?
Because cosine x is it's the second derivative.
Good. Second derivative of the first. Okay. In fact, I don't even think there was a chain rule in there. Well, yeah, there wasn't, but I just want you to compare these two problems because one of them has a product, and probably that's the one that's a little harder, and one of them doesn't. Okay, but we have to see that, therefore, they both require a different sort of philosophy. I heard you girls talking about if you simplified this or not, all that stuff's kind of small potatoes. There's really nothing you need to do here. The negative maybe should come out front. The 2 maybe should be in front of cosine. If we're going to rewrite it, we might as well do that. But again, you don't really need to factor, and the most important thing is that everyone says product rule versus chain rule. Okay, now a lot of stuff that I showed you today, it was kind of on purpose. Tomorrow we'll have a few more problems that sort of let you test some of this, and then we're going to do something that would be considered more of a end of the lesson. It's not an exit ticket, but it is kind of a problem that kind of puts all this together. So, but a little quicker turnaround. The assignment members actually due Thursday. I know that seems like some time away, but you could start it. The assignment takes a little longer. I'll sort of share that with you. It does take a little longer. So you have enough information that you could start working on it tonight if that sort of fits your schedule. Okay.